Hello and welcome to Golden Geography. Today we're going to be talking a little bit about the Earth's Life Support Systems unit for the OCR Geography A-level specification. And we're going to be focusing on key question 1, which is how important are the water and carbon cycles to life on Earth? And we're going to start by thinking a little bit about question 1A. The water and carbon support life on Earth and move between the land, oceans and atmosphere. Well, we're going to think a little bit about the water cycle in this video. There is a similar video for carbon if you'd like to look at that one. We're going to start by thinking about the importance of water for supporting life on our planet. It is absolutely essential. We're called the blue planet for a reason, because when you look at the planet from outer space, it appears blue because of the water we have, the water in our oceans. But we also have water in our atmosphere, and most importantly, within our biosphere, within the plants and the animals, the flora and fauna that are found on our planet. And if we think about us and our lives, water is absolutely essential to our lives and life for us. We drink it. We use it to cook our food, to wash ourselves, our clothes, our cars. We use it in the manufacturing of products. We use it to grow food. We use it in agriculture. We use it to wash food. We use it in so many different ways that we could not survive if we did not have water. Water is absolutely essential for human beings. But it is also important for our flora, the plants that we have on our planet, and our fauna, our animals, who use it for many of the similar biological processes that we use it for. Well, how is it important for us? It is essential for a whole range of different reasons. Drinking particularly, water, pure water, the drinking of water, is essential for biological processes. It is essential for the growth of plants, and we use it within cooking, drinking, use it for sanitation. There are many, many uses of water that human beings have, and it's really essential for us. So, seeing how important water is, we need to think a little bit about the water cycle, how that works and functions. Where do we find water? How does it move between different stores? And how can we access that water as human beings? So the water cycle is the movement of water either through an open or a closed system, more of that later. It can be stored in lakes, in the ground, in ice, in our atmosphere, but it also moves between that in different processes, anything from evaporation to precipitation. So the movement of water from land to ocean to atmosphere is really important. And some of those key movement processes are called evaporation, condensation, precipitation, runoff and infiltration. There are more we'll come back to later, but those are the key ways water moves around our planet and from one part of the cycle to another. When we think a little bit about water and the water cycle, we need to think about the water cycle as an open system. So this might be for one particular area or drainage basin. It may be looking at a particular forest area or a desert area and how the water functions, the water cycle functions in that particular biome or drainage basin. For example, the Thames and the Thames River Basin. Or you could look at it as a closed system, which is looking at it on a global scale. Water doesn't really enter or leave our planet, so there's no additions, no real inputs or outputs. It's just changing the state and the store on a global scale. Therefore, it's a closed system. So open systems will experience seasonality. Water will come and go. Inputs and outputs will vary. Small scale, local scale. Closed systems are global. Don't tend to have those inputs and outputs in the same way. The volume of water doesn't change. Okay, let's think a little bit about how the water cycle functions with its inputs, outputs and so if we think about the water cycle, it has distinctive inputs. Most of these are precipitation. So if we're thinking about precipitation, it varies where you find your location or place on the planet. So if you are in tropical regions, you will predominantly have rain. If you are in polar regions, you'll predominantly have snow. And if you're as fortunate as we are to live in the UK, you'll have a variety of everything. So these are going to be your main inputs in your water cycle. There may be seasonality that influences the amount you get or the type that you get, but very much influenced by your latitude and longitude. Those inputs will then go through stages of storage or processes, and we'll look at those in a moment, but you then get your outputs, which tend to be evaporation, transpiration, ablation and sublimation, ways in which water leaves the system. But remember, it's a cycle, so it will go round. So very often these inputs and outputs can also be termed as processes. They have more than one role. If we think a little bit about where water is stored, then we've got a whole variety of different places we can look on our planet. We've got lots of water stored in our atmosphere, and that tends to have quite a short residence time. We have water in our oceans in a very saline condition. We have bodies of water like lakes, but we also have ice that stores water for a very long residence time. We get water in our soils, in our vegetation, in our groundwater. So all of these are really important stores of water with different levels of accessibility for human use. So most water that we as human beings use comes either from rivers or from groundwater, not so much from our oceans or our ice or atmosphere at the moment, but very important stores, all of them. If we look at the amount that we have, we've got different sizes. So obviously our oceans, we are a blue planet. Our oceans have the largest amount of water and quite a long residence time, but not as long as some of our cryospheres. Areas that have much shorter tend to be our atmosphere, with generally less than 10 days. So a particle of water will be in our clouds for less than 10 days on average before it falls again. Feel free to pause this video at this point and have a little look at those different stores, their sizes and those residence times. And then finally we want to think a little bit about what links those different stores together and those inputs and outputs. And that's the processes or flows within the water cycle. So if we think a little bit about evaporation first, it is most definitely an output, but it is also a process or a movement, a flow of water. It is very important that evaporation takes place. It can take place off a body of water like a lake, reservoir. It can take place off your rooftop. It can take place off vegetation as well. But it does involve thermal energy. You do need to have enough heat to break some of those bonds between the water particles, to break them down and enable them to have the energy to evaporate. So in terms of the speed of evaporation or the rates of evaporation, they tend to be much higher in our tropical areas and very low in our polar areas. They do vary. There are other things that might influence that too, like the surface area you've got, how deep your water is, what human activity is taking place, and even things like wind speed might influence your rate of evaporation. We have transpiration, similar process, but here you're looking at your biomass. That process of photosynthesis uses water, and as a part of that process, water escapes the plants through their stomata back into the atmosphere. So it's drawn in through the roots, used as part of photosynthesis, escapes through the stomata back into the atmosphere. So it goes from a liquid state to a gas state. And rates of transpiration are really important as a part of that transition from liquid to gas, but it's also really important for our biomass and ties in a lot with the carbon cycle. Again, it varies. There is an element of seasonality to it. When you're looking at a globe, the majority of the land mass is in the northern hemisphere. So when the northern hemisphere has its summer, there are higher rates of transpiration than there are in the winter time. even though there are land masses in the southern hemisphere, it doesn't balance out. So there is a seasonality to transpiration. Processes, of course, they have to involve clouds, the formation of clouds. And here you're looking at how water vapour, once it's evaporated or gone through the process of sublimation, gone into the atmosphere, how then as it rises through the atmosphere, it cools and condenses, and it will condense around some condensation nuclei, often a bit of dust or something else that's in the atmosphere, and it will condense around it. And that tends to happen at very specific temperatures, and it's called the dew point. Have a little look at that one up. And once that process starts happening, you might find it won't just be one, but maybe 2 or 3 bits of water start to gather together. It generates a water droplet that will increase in mass, and then it will start to eventually fall as precipitation. It will form different clouds, different shapes of clouds, different styles of clouds, depending on the amount of energy, thermal energy involved, the amount of water vapour involved, and where it actually is in the atmosphere too. The very light, fluffy ones happen much higher in the atmosphere than the much more denser ones. And of course, we get different types of precipitation tied into different types of cloud. But that formation of clouds and the condensation that takes place within them that then leads to precipitation is really key. And when we think about precipitation, there's lots of different types. We've got some of the main ones here. But the key thing to note is the variations of precipitation happen because of the atmospheric temperatures that is falling through. So very often, most of the time, you will find that as water condenses, it will form snow first of all. And if temperatures between the clouds and the ground are at freezing or below, it will fall as snow. It's only when those temperatures start to rise that you will then start to get different types of precipitation. And if those temperatures are significantly high, so 2 or 3 degrees above Celsius, then it will fall as rain. Those snowflakes will melt and fall as rain as they hit the ground. As it falls, it will be intercepted. This can happen by anything, but for us the most important one to consider really are plants. So this could be a tree, as we can see in the diagram here. It could be a bush, it could be grass, but trees are much bigger forms of biomass that have a greater canopy and a greater capacity to intercept material. That interception means that water can be guided by the plant through stem flow into the ground and then used by the soil as soil moisture and ground moisture, or by the vegetation itself. It also produces a canopy, an area beneath the canopy, where conditions are slightly different. There's less water there. There'll be some dripping off of the leaves, but there'll be less water there compared to beyond the canopy. So interception is really important. It can lead to evaporation. The canopy can hold water and lead to evaporation, or you can get slowly dripping and movement of water down through your vegetation. We also have ablation. This is a really good link for those of you who do glaciation to that. Ablation is the melting and the retreating of your glacier. So you've got that zone of ablation at the end of your glacier. And here this is where your ice will slowly turn to water, and you can get glaciofluvial processes and landforms. You will also find that you'll get sublimation, where the ice turns, or snow turns directly into water vapour. And you'll also find that you can get things like calving, where blocks of ice break off first and then will ablate too. So this kind of changes that happen in our glacial environment, the ablation particularly is really important as part of that process, because here you're releasing water that has been stored for a very long time. Glaciers have a long residence time. And then we have runoff. You will get this tied into glaciers, that meltwater we've just been talking about, but you will find this associated with rivers, areas of wetlands, areas that are boggy, anywhere where you have very intense rainfall that exceeds the soil capacity to absorb it and for that infiltration to occur. So this can happen very often here in the UK. It can happen particularly kind of February, March time if we've had a very wet winter. It's after we've had that period of recharge, soil recharge during the autumn months. Two main types of runoff or overland flow. Overland flow just happens when you've got that rainwater which flows across the land surface. It's where your rain is so heavy it exceeds the rate of infiltration, regardless of the state of your soils or the geology beneath it. It will particularly happen in areas where you've got hard or compacted soils or areas of impermeable surfaces, so in urban areas. Saturated overland flow is when the soil is fully saturated after it's experienced recharge over your winter period, and therefore there's no more space as such for infiltration, so the water just runs overland and into your rivers. Which leads us to catchment hydrology. These are very much our open basins, our drainage basins that are open, so you will have varying inputs because of seasonality or location on the planet, but also you have varying outputs depending on seasonality. So in summer you will find evaporation levels will be much higher than in winter because of those temperature changes. So catchment hydrology is the study of the movement of water, the distribution of water within a set drainage basin. Drainage basins can change in size and shape, they can have different amount of tributaries, all that will influence that water cycle and the movement of water through it. But things like infiltration and percolation and through flow, groundwater flow, and even ice or the absence of ice will influence how and where water is stored within a drainage basin. So you will find that these vary significantly. And when you look at case studies later on of rainforests and compare them to tundra, you'll see that these basins, these drainage basins, because of their geography, their latitude and longitude, the way they function within the water cycle vary significantly. But do investigate your own local one. Okay, so thank you for listening. Pause, review what you've learnt. You've got 3 key questions here. Green for I get it, amber for I need to think about it a little bit, maybe do a bit more research. Red, I really need to go back to the beginning, think about that some more, get some help. So red, amber, green, these 3 key questions, and if you need to, pause and rewind the video. Thanks for listening.